This is a great question because it relates to what we've talked about before in this class. We have 15 minutes. I've set the timer. We'll get halfway through before lunch. For 0 to 12, particle moves along the x-axis. Velocity of the particle at time t is given by this. Particle at position x equals -2 at time 0. So I'm given a velocity function. That is a velocity function. It's the first thing I note. And I look to the first problem. It says, when is the particle moving to the left? Well, what is true about the velocity if the particle is moving to the left? So I'm going to look for v of t to be less than 0. I'm going to look for where that's negative. And the AP graders like it when you communicate your work to them. So I'm looking for that. That tells them, okay, they know what they're doing. This is a no calculator problem. So therefore, if I want to look at where it's negative, I'm going to look at where the graph is below the x-axis, okay? So I need to graph cosine. What's the maximum value? What's the minimum value? How do I figure out the period? What's b? Multiply by 6 over pi, what do I get? 12. So if I get 12 and I mark it off, starts up, goes down. So by looking at this graph, where is it below the x-axis? So there's a couple ways of expressing your answer. 3 is less than t, which is less than 9. It would be great if you could state this, and the AP people appreciate when you write them a sentence and say moving to the left from t equals 3 to t equals 9, or the particle is moving to the left from t equals 3 to t equals 9. Are we given any units in this problem? No, so that's it. No, they showed this in the answer key. So if you just said this is an answer, like boxed it, they might say, okay, we see that they know what they're doing. But, you know, don't put stress on the graders. Give them reason to get you answers. Try to communicate. And from the people that took the test last year, they said that they had more than enough time on the free response questions. Mostly because, you know, a lot of them were just confused. So when you know what you're doing, take time to communicate what you're doing. So we go to B. All right? So it says, write but do not evaluate an integral expression that gives the total distance traveled from the particle. Oh, boy. Total distance, what does that tell you? Absolute value of the integral, right? So the total distance, if I said displacement, I would just do the integral from what time to what time? 0 to 6 of v of t dt. But because it's asking for the total distance, we have to include the positive and the negative, put that absolute value sign in front. They just need you to communicate it accurately. So because v of t is this function, you could just write v of t. If you want to write cosine of pi over 6 over t, go ahead. But you could just leave it exactly like this if you want. Oh, yeah, definitely. And I'll show you the answer key and how we score it in not too long. Hey, free points. Don't get that one wrong on the test. All right, problem C. It says, find the acceleration of the particle at time t. Well, how do I find the acceleration if I'm given the velocity? I take the derivative of the velocity function. How will I take the derivative of this velocity function, which is cosine of pi over 6t? The chain rule. Yep. So cosine of u, pi over 6t. Thank you. And derivative is pi over 6. Antiderivative cosine of u is negative sine of u. Now, what I'm hoping is that the AP graders at some point are like, boy, who's that math teacher that's teaching the kids how to use those boxes? Like, that's such a great idea. We should start using that in our textbooks. But if you start using the boxes and you get the answer wrong, then they're going to be like, dude. I started using the boxes and the arrow because one time I taught a class I used a chain rule, but I wasn't in class that day. I made a video and I was like, well, I gotta have something to help them out. Yeah. So anyway, yeah. So I've got pi over 6, and it's negative times sine of pi over 6 t. So that's my derivative, meaning that is the acceleration. Now note what the question is asking. It says the acceleration at time t. This is an expression for the acceleration at time t. The second part of the question is a very, very, very common question to ask. It says, is the speed of the particle increasing or decreasing or neither at that time? And for that point, I will pause the video to do this demonstration. In order to determine if we're speeding up or slowing down, we have to check acceleration at time 4 and velocity at time 4. Well, velocity at time 4 is going to be the cosine of pi over 6 times 4. What's 4 times pi over 6? 2 pi over 3, and then the cosine of 2 pi over 3, that's 120 degrees. This coordinate is negative 1/2 root of 3 over 2. So again, you don't get your calculator for this problem, so you have to be able to do that, which is tough for some people. So what's the cosine? Negative 1/2, right? And then the acceleration is going to be the derivative. So negative pi over 6 times, what's the sine of 2 pi over 3? Root of 3 over 2. So you get negative pi roots of 3 over 12. And so are they the same sign or opposite signs? Same sign. So we say speed is increasing because A of 4 and V of 4 are same sign. No. And I'll show you the scoring. They will not. Okay. I believe that they give you a point. I believe they give you a point for coming up with the acceleration equation. They give you a point for checking A of 4 and B of 4. And then they give you a point for stating that it's increasing because of this. Okay. So last problem, problem D. It says position. Well, position is easy. You guys told me position is equal to the starting point plus the displacement, right? We've done that kind of problem before, haven't we? Well, what's the starting point? Negative 2 plus the displacement. How do we figure out displacement? Integral from 0 to 4 of cosine of pi over 6 t dt. I got to find the antiderivative of cosine of pi over 6 t. Substitution, very good. So u is equal to pi over 6 t. So du is pi over 6 dt. So I have to multiply. I have to get rid of the pi over 6. I don't have a pi over 6 there. So 6 over pi du is equal to dt. So it becomes 6 over pi times the integral of cosine of u du. What's the antiderivative of cosine? sine. So we get 6 over pi times the sine of pi over 6 t. That's the antiderivative. Well, we got to evaluate it at 0 and 4 and then add -2. So -2 plus our 6 over pi times the sine of pi over 6 t evaluated at 0 and 4. What's the sine of 0? 0. But the cosine of 0 is 1. So as long as we don't have cosine, we're okay. So I got a sine of 0, 0. But if I plug in 4, that's 2 pi over 3. Do you already know the sine of 2 pi over 3? Yeah, it was what? It was root of 3 over 2. So you have -2 plus 6 over pi times the root of 3 over 2. Now, if you leave it like that, they will give you full credit. If you simplify it, -2 plus 3 roots of 3 over pi, they'll also give you full credit. Okay, can I show you how they score this? Here's what you're going to do, okay? One of our... Okay, if you go to my website and you click on AP Materials, look at what I have. It says free response. Now, what year are we working? What free response year are we working on? So look at 2012. There's 2 parts here. There's 2012 PDF. There's 2012 SG PDF. That means scoring guide. And so when you click view for the scoring guide, which problem number from 2012 did we work on? Problem number 6. So let's see what we have. It says right here, particle moving left, v of t is less than 0. This occurs from between 3 and 9. So number 1 considers v of t equals 0, and this one, looking at the interval. We looked at the graph where it's equal to 0. I think that's probably good enough. We also said less than 0. So it tells you 2 points for that. We got 1 point for the absolute value piece. It says 1 point for finding a of t, and then 2 points for the conclusion with the reason. They don't split it up 1 and 1. It's 2 points either way. And then look at this nice answer. -2 plus 3 roots of 3 over pi. 1 for the antiderivative, which required substitution. 1 for the use of the initial condition, which is -2. And then 1 for coming up with the right answer. So, again, this is 9 out of 9. And you know, I would say you're doing very good to get all that. Yeah, exactly. Exactly. So there's a lot of ways to generate points in these type of problems. So you're going to try to score yourself tonight on your problem, see how you do. Let's move to the next one. Move to the very front page. And you're going to need your calculator for this one. I'm going to warn you guys, this one's a pretty challenging problem, but since you're an excellent class and you're probably smarter than everybody else, I'm going to do the challenging problem with you, okay? All right? Thank you for your work ethic and being excited about that. It says on a certain workday, the rate in tons per hour which unprocessed gravel arrives at a gravel processing plant is modeled by this. So basically, we have gravel that is coming in, and it makes this bin of unprocessed gravel, and then we process it. Okay? That's what's happening. So this is the rate. So again, we're given a rate function, which I like, because that's similar to what we've been given before. And it's given by that. And notice this is a calculator problem here. Okay? At the beginning of the day, plant has 500 tons of unprocessed gravel. So there's 500 here to begin with. During the hours of operation, plant processed gravel constant rate of 100 tons per hour. So this is a rate of 100 tons per hour that it's being processed. Okay? So I did this problem, and I got 8 out of 9. I made a mistake on this one. I'll show you where I made it. It's kind of tricky to see where it is, but I got it incorrect. It says, find G prime of 5 using correct units. Interpret your answer in context of the problem. Well, this is G. How would I find G prime? Derivative. Can I do that on my calculator? Yeah. So take out your calculator. Let's do it. I'm going to go to y equals, I'm going to type in the function. Should I be in degrees or radians? Radians. Be in radians all the time on your AP exam. And I'm going to consider the actual graph. I know that this is challenging, but trust me, you want to stick through this and really see the problem all the way through and trust that you don't have to pick up every bit of it, but you want to pick up, a lot of parts. So we look at this piece right here, and what is wrong with you? Okay, just go away. Oh. Okay, look at this function. What's the amplitude? And it's shifted up 9 units. So what's the maximum value of that graph? 135. So if I go into my window and I change my x min and x max to 1010, which is fine, but I go my y min to negative 150 and positive 150, will I then see the whole graph? Yeah, so I press graph, and now I get a nice picture of it. So if you press graph right away, it might not have worked out too well for you. So I'm going to do part A, which is g prime of 5 is equal to, how do I find that on my calculator? Second calculate. 6 is the derivative. Whoop, that didn't work too well. Calculate number 6, and what is the spot at which I'm evaluating the derivative? So I press in 5, you have to go to 3 decimal places. So negative 24.588. And it's measured in tons per hour. If I take the derivative of tons per hour, what do I get? Tons per hour squared, okay? So what does this mean? This means the rate at which the gravel is arriving to the plant is the rate at which is arriving increasing or decreasing? Is decreasing at a rate of 24.588 tons per hour squared. How's that? I know that that's challenging. Trust me that we're going to do a lot of this, and hopefully you'll get used to it. I think that a lot of times this is the hardest day. That's a good question. Do you have to say at time 5? I would say that that would be a great thing to say. We'll check the answer key and see what they say about it, but it would be good to have that. B, find the total amount. When you hear find the total amount, that's like another thing. That's another way of saying find the total displacement. Okay, find the accumulation. How do I do that? How did we find distance or displacement? What did we use? We used our integral. So when it says find the total amount, we just use the integral. If we take the integral of a rate, that's going to give us a total accumulation, whether that be distance or amounts. And it says during the hours of operation. What are the hours of operation? 0 to 8. And I'm going to use g of t dt. Always set up the integral so they know what you're doing. Don't just put down the answer, okay? Tell them what you plugged into your calculator. So I'm going to do second calculate, and I'm going to do numbers, what? 7. I'm going to go from 0 to 8. And I get 825.551 what? Tons. There's that many tons of material that are brought in. Okay. It says, problem C, this is where I got my point off. It says, is the amount of unprocessed gravel at the plant increasing or decreasing? Now, look at the graph. This is a rate. The graph is a rate. Is the graph positive or negative? It's positive. So that means that we're always bringing material to the plant. We are always bringing material. That's always positive. But are we also processing material? We are. How much are we processing? 100, right? So if we're bringing in 120 but processing 100, is the amount of unprocessed gravel increasing or decreasing? Increasing. If we're bringing in 90 but we're processing 100, are we increasing or decreasing? Decreasing. So let's find out how much we're actually processing at time, what is it? So we're going to figure out the value at time 5. It says that it's coming in at a rate of 91 or 98.141. So G of 5 is 98.141. How does that compare to 100? It's less than 100. So the amount of gravel is decreasing. What do you think I put for an answer? Increasing, because I said it's bringing in 98 tons per hour. Okay? The amount of gravel is increasing. They continue to bring it in. I forgot about the fact that they're taking it away. Last part, D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation this workday? This is a challenging problem. Okay, how about this? As long as they're bringing in more gravel than they're processing, the amount's going up, right? So wouldn't it be nice to know when the amount of gravel that they're bringing in how much are they processing? Minus 100. Would be nice to know when that's equal to 0. Okay. So this is asking for a maximum. If I want to find a maximum, that's where the derivative changes from positive to negative. If you take the derivative of this, what's left? If you take the derivative of this expression, what goes away? Yeah, you're just left with g of x minus 100, right? Let's find out where that's equal to 0. So let's look at our graph. Y equals, I'm just going to subtract 100 off of that. I'm going to look at where it equals 0, graph. Let's see if it changes from positive to negative. Changes from positive to negative. Looks like right about there, huh? How do we find that exact spot? Second, calculate 0. So I go over here. We're almost done. I go enter. I go enter. And enter. And it tells me I get x is 4.92348. So now I'm going to figure out what that amount is. I'm going to second calculate number 7. And I'm going to integrate from 0 to 4.92348. And so this is 135.376. But how much did I start with? I started with 500. So 635.376 tons is the most amount of gravel that they have there at any time. I totally understand if you didn't catch every bit of that free response question. Raise your hand if you think you're probably confused about at least a portion of it. That's entirely normal. Don't feel bad. As we continue to go through, there's going to be parts where you're like, you know what, I don't think I'm going to remember that, but I think I will remember this. Let's check our answer key real quick. What year was that? Okay, so 2013. I'm going to view that scoring guide. What problem number was it? Problem 1? Yeah, it is. Okay, so it looks like we've got G prime of 5 is correct there. Looks like the 825 was correct. 98.1 was less than 100. We did a good job of processing that. We didn't set up the integral quite that nice looking, but we did have the 500 plus in there. And we had the 4.92, and we did have the final answer of 635. So your assignment, if you would like to take it home to work on it or take the whole thing home, that's fine. But in the end, you will put it back in there, okay? Because we're going to give you more of this stuff. I want you guys to try problem 2 on your own and see if you can score yourself. I will then show you just 2. That's all I'm asking you to do. So if you have the time, then score it by looking at this stuff tonight. If you don't have the time, we're going to do it tomorrow, and I'm going to score it for you guys. But do not show up tomorrow without giving it an honest shot. If you don't get it scored, fine, but at least give it an honest shot. That means at least 15 minutes.